class. We're gonna finish the last few problems from our practice test / study guide. So let's take a look at problem number 17. So here's another multiplication problem. Again, distributed property, combine like terms, I squared is equal to -1, and simplify completely. So the first thing we're gonna do is, we've got 7 times 9, and that's gonna be 63. 7 times -6i is -42i. Now I've gotta do my 2i. So 2i times 9 is 18i. 2i times 6 is a -12i squared. Why is it a negative? Because we have a positive 2 times a -6, and a positive times a negative is negative. So let's go ahead and combine any like terms. And I see in the middle we have some like terms here, so I'm gonna bring down my 63. I know my answer is gonna be negative because I got more negative than positive. And let's see what -42 and 18 will give me. Make this quick. That will give me -24i. Here I'm gonna go ahead and rewrite this as -1. So a -1 times a -12 is a positive 12. All right, so this is what I did. I just replaced that with -1. And I'm almost done. But now I've got these two like terms that I've got to work on. So 63 plus 12 will give me 75 minus 24i. Now here is the final answer for that. Okay, let's go ahead and do problem number 18. This is the first problem that we're doing, that's division. Notice that we've got 7 plus 3i divided by -3i. In order to divide complex numbers, we found out that we've got to multiply by the conjugate of the denominator. Then we will do what we normally do with multiplication, whereas we use the distributive property, combine like terms, I squared equals -1, and simplify completely. Now what is a conjugate? The conjugate is when you take a complex number and you give its opposite. In other words, the conjugate of -3i is +3i. So I'm gonna multiply by the conjugate, which is 3i, over itself. There's a reason we can do this, because any expression over itself is equal to 1. So what I've essentially done is taken the original problem times 1, which has not changed the value of the problem, but I'm using it in order to solve this division. So let's go ahead and do the work. So I'm gonna multiply 7 plus 3i times 3i. So 3i times 7 gives me, I'm gonna put this down here, 21i. 3i times 3i is 9i squared. Because remember, I have 3 times 3, 9. I times I squared. And this is gonna be over -3 times -3 is, times +3 is -9. I times I is I squared. All right, now you remember what we do with those I squareds? That's right, change them into -1. So this will become 21i plus 9 times -1 over -9 times -1. Interesting. So let's do the work. 21i minus 9. How did I get -9? 9 times -1. That's how. Over a negative times a negative is a +9. All right, so I'm almost done. In fact, this is my answer. However, we're gonna rewrite it because we want it to look like a complex number. So what I'm going to do is I'm going to literally rewrite the numerators and give each term the common denominator. What do I mean by that? 21i over 9 minus 9 over 9. Okay? But look, these can be simplified because 21 and 9 have a 3 in common. They have a common denominator. So I'm gonna rewrite this as 7. 3 goes into 21, 7 over 3. But don't forget your I. And here, what is 9 divided by 9? Well, what's anything divided by itself? 1. So this will be -1. And again, it's almost in that complex number format. It's just that we normally have the real part first and then the imaginary part. So I'm gonna flip-flop those. I'm gonna use the commutative property and switch them around. The real part is -1. Don't forget the negative. And the imaginary part is 7i over 3. And it's positive because there's no negative in front of it. So So this is our final answer for number 18. Let's take a look at 19. Now, I've already written the conjugate over itself, so we can go ahead and start doing the work. So I'm gonna put this down here. 4 times 5 is 20. 4 times 3i is 12i. Done with the top. It's the bottom that's gonna be a little bit longer. 5 times 5 is 25. 5 times 3i is 15i. Now let's do the negative 3i times 5, which is negative 15i. Negative 3 times negative 3 is negative 9, but the I times I is I squared. Told you it was a little longer at the bottom. Okay, let's see what we can do here. I'm going to rewrite the top because there's nothing I can do with the top. But look at the bottom. There's a lot we can do. The positive 15i and the negative 15i cancel each other out. No more middle term. The I squared can be written as negative 1. So I'm gonna do that now. Save myself some time and space. Now let's see what's left here. So I've got the 25. A negative 9 times a negative 1. Negative times a negative is a positive 9, so plus 9. Okay, see what we can do. I've got 20 plus 12i over, what is that, 34? Okay, of course I'm going to do what I did up here. I'm gonna give the numerators the common denominators separately, because we wanna get this in real part and imaginary part form. So this becomes 20 over 34 plus 12i over 34. And let's look to see if we can simplify the numerators and denominators. We can, because they are even. 2 will divide any even number, so let's use 2. So 2 goes into 20 10 times and 34 7 times. There's my real part, plus I can use 2 for the 12 and the 34 also. 2 goes into 12i, 6i times 34 17. So here is my answer, and it's in complex number form, the real part plus the imaginary part. Number 20. Who can tell me what the conjugate of the denominator is for number 20? You're right, 2 plus I. So I'm gonna multiply by the conjugate over itself. And we've got some division to do, don't we? Let's do this division. Gonna be a little long. So 3 times 2 is 6, 3 times I is 3i. Negative I times 2 is negative 2i. Negative I times positive I is negative I squared. Done with the top. Let's get the bottom. 2 times 2, 4. 2 times I, 2i. Negative I times 2, negative 2i. Negative I times I is negative I squared. Not too bad. Now, what can we do? Well, we can combine like terms here. So I see 6 plus I, because 3i minus 2i is 1i. And I do not have to put the 1 in front of the I. Minus I squared over, notice how these cancel each other out? Notice that those middle terms in the denominator always cancel each other out. So 4 minus I squared. Do we know what I squared is? Yeah, it's negative 1. So I'm gonna rewrite that as 6 plus I minus negative 1. And underneath 4 minus negative 1. Because keep in mind, I literally erased this, put negative 1 in place of it. So that minus is still there. See that? I erased this. Imagine me erasing this and replacing it with negative 1. That's what I did. This negative is not the negative that comes with the negative 1 that we replace with I squared. So be careful. Students will make that mistake a lot. Now, let's see what else can we do. So I've got 6, well, a minus 1. That's called a double negative. So a negative times a negative turns into a positive. So this becomes 6 plus I plus 1. A double negative turns this into a positive 1. Same here. 4 minus a negative 1 becomes 4 plus 1. And lastly, I can put the 6 and the 1 together. That gives me 7 plus I, and the 4 plus 1 is 5. Now I can write this as 7 over 5 plus I over 5. And this will be the real part and the imaginary part. Because I couldn't simplify 7 and 5, they're both prime. Now the last problem, same thing. What's the conjugate? That's right, it's 5 minus 2i. Okay, let's get some work going. We gotta do some multiplying. It's gonna be a nice long fraction bar. 4 times 5, 20. 4 times negative 2, negative 8i. Negative 2i times 5, negative 10i. Negative 2i times a negative 2i is a positive 4i squared. Okay? Now let's do the bottom. 5 times 5, 25. 5 times negative 2, negative 10i. 2i times 5, positive 10i. You see where we're going to cancel these out? And then 2i times negative 2i is a negative 4i squared. Okay, what can we do? Let's combine these like terms in the middle at the top. 20, a negative 8i and a negative 10i is a negative 18i plus, now here I'm going to go ahead and replace my I squared with negative 1. Go ahead and get that out the way. At the bottom, these cancel. We're left with 25 minus 4 times negative 1. So we'll go ahead and replace that. Okay, what do we have on top? Well, 20 minus 4. How is this a minus 4? Because a positive times a negative is a minus. So 20 minus 4 will yield 16, and then the negative 18i is still there, okay? And here, 25 plus 4. How do I know? A negative times a negative is a positive 4. Is 29. So here's my answer. Of course, I'm going to pull those numerators apart. And let's put 16 over 29 minus 18i over 29. Now, there's no common denominators, or sorry, common factors for me to simplify. And it's in real part and imaginary part, so it's in complex number form. So we're going to leave it like that. And we're done. So hopefully you get a chance to verify your answer in case you got it right the first time, or check your answer and see where you may have made mistakes. All right, and we're done.